बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन। Since I'm using full screen, I have also opened YouTube on my phone so I can read your comments. I hope you are all doing great and tackling your P3 preparations with confidence and focus. In this class, I will do some important questions of complex numbers. Let's begin the class. This question is from November 24, paper 33. Question number 1. The complex number z satisfies modulus z is equal to 2, which means equation of circle with center at origin and radius 2. And this is the argument of z. It lies between 0 and pi by 4 inclusive. On the Argand diagram below, sketch the locus of the points representing z. So we have to draw a circle of radius 2 with center at origin, and here argument from origin, and pi by 4 means y is equal to x. So first draw circle of radius 2. And argument z pi by 4 means y is equal to x. This is pi by 4. Just 1 minute. I'm sorry. Okay, so this is part A. This means circle, center of origin and radius 2. I minus 2 minus 2i, and this is the line of argument z. Now we have to shade this region. Argument z is between 0 and pi by 4. So shade this part. This is the required region. Part B. On the same diagram, sketch the locus of the points representing z square. When you will square this, you will get z square is equal to 4. So draw a circle with center at origin and radius 4. This is 4i minus 4 minus 4i, and shade this part as well. Why? Because argument z lies between 0 and pi by 4. So this is the required region of z. This is done. Now the next question of this paper is question number 4. Well, this is an important question because it involves a lot of algebra. I'm sorry. So find the complex number z satisfying the equation and give your answer in this form. Remember, whenever we have an equation with one variable, one equation with one variable, so always replace that variable by x plus iy. So by replacing all z's by x plus iy into given equation, we have this is the left side of this equation. I replace this z and this z by x plus iy. On right side, just copy the equation. Now use bracket and do cross multiplication. This 5 will come here. So 5x plus 5yi or iy, they both mean the same thing, 15i. On right side, be careful. This 2 will first multiply with this bracket. X plus iy plus 3i. Do it with great concentration so that you can avoid careless mistakes. So 2x, this is 9i, plus 2yi, 6i, 9xi, minus 9yi square, minus 27i square. Now bring everything on right side or left side, you have option. I'm shifting all these terms on right side. So we have minus 5x minus 5yi minus 15i plus 2x. See, I shifted all these terms on right side, so this would become negative, negative, and this will become positive. Now copy all these and simplify I squares as well. So 2x plus 2yi, 6i, sorry, minus 9xi. This I square will become minus 1, so we will get plus 9y and plus 27, because I square will become minus 1. Now check the terms. Minus 5x plus 2x. This will become minus 3x. Minus 5yi, 2yi, that's it. So minus 3yi. Next, 15i and 6i. This will become 21i. Next, copy this minus 9xi, copy 9y and copy 27. Now separate the real parts and imaginary parts. So minus 3x plus 9y plus 27 is you can write this as it is, and you can write this 0 as 0 plus 0i, because we will equate real part with real and imaginary with imaginary. Now write minus, okay, I use this and this here. Now copy minus 3yi, just 3y, I will take I common, minus 9x plus 21, 0 plus 0i. This and this. We took all three here and I is common. Now equate the real part with real, this part with real 0, and this part with real, imaginary with 0. So we have minus 3x plus 9y plus 27 is equal to 0, and minus 3y minus 9x plus 21 is equal to 0. Okay, I'm multiplying this equation with 3. Then I will do elimination. So I'll get, when I will multiply this equation with 3, I'll get minus 27x minus 9y and 63. Now I'm doing elimination of this and this. So we have minus 3x, this equation is here, so y, both y's are cancelled, therefore we have minus 30x here, and I think 7 plus 3, 90. Therefore x is 3 and y would be, when we will substitute 3 here, we will get minus 2. Hence, the required complex number is 3 minus 2i. You can check the solution again. Sorry. One message for everyone: share this video with all your contacts, and if you find my YouTube channel helpful for you and other students, I would be truly grateful if you subscribe and share it with your friends. I'm sorry. Next question. Next question is from November 24, paper 3-2. Question number 3. The question is, the square roots of 6 minus 8i can be expressed in Cartesian form. This is known as Cartesian form, x plus iy, by first forming a quartic equation, power 4 equation. In x or y, find the square roots of this in exact Cartesian form. So this question is of 2 square root, a very famous question of complex number. So first, let this as x plus iy, 2 square roots, so use under root, 6 minus 8i. Then squaring on both sides. Then expand the expansion x plus iy. Give me just a few seconds. Okay, so x plus iy, expand this by means of a plus b whole square. So x square 2xyi iy square six minus 8i. Now we have x square, this will become minus y square. I square is minus 1. So minus y square 2xyi 6 minus 8i. Now equate real part with real and imaginary with imaginary. So x square minus y square is equal to 6 and 2xy is equal to minus 8. Now find either x or y from this equation. So I'm finding y. So it's minus 4 upon x. Now substitute this into this equation. So we have x square copied, same y square. We can substitute y by minus 4 upon x, and square is here and 6 is here. So we have x square minus 16 over x square is equal to 6. After taking LCM, we have x power 4 minus 16 over x square is equal to 6. Now do cross multiplication. So we have x power 4 minus 16, 6x square. Now arrange the equation to 0. And break the middle term. The factors are 8 and 2. Because 8 times 2 makes 16. So we have x square common from first two terms, and from last two we can get 2 common. Now we have two values of x. Okay, I'm using next page to make the to keep the calculation simple. So x square is equal to minus 2 or x square is equal to 8. Remember, x and y both are real numbers, so this will be invalid. And from here we will get plus minus under root 8, which will become plus minus 2 root 2. So these are the values of x. It's mentioned x and y are real. That is why I ignore negative answer. This one. Now the next we need y, and y was minus 4 upon x. So substitute 2 root 2 first. X is 2 root 2. So minus 4 upon 2 root 2, which will become minus 2 upon root 2. Now rationalize this. When you will rationalize this, this is the rationalization, you will get minus 2 root 2, or you can do this in calculator as well. So y is minus root 2. So when x is 2 root 2 positive, then y is negative root 2. Therefore, when x is minus 2 root 2, then y must be positive root 2. Hence, the two square roots are x plus iy, 2 root 2 minus root 2i. This is the first root. And the second one, minus 2 root 2 plus root 2i. Now check this solution. I'm taking 1 minute break. Allah. I'm repeating, if you find my YouTube channel helpful for you and other students, I would be truly grateful if you subscribe and share it with your friends. You should also share the link of this live session. Now the next question is question number 5. A very important question of the same paper. I'm sorry. Thank you. I'm reading your comments. Thank you, everyone. All right. So question number 5A. Find the exact value of argument u. So first, for argument, this complex number must be of this form. The standard form. U r cos theta plus I sin theta. We must have this form. So we need to remove I from denominator, and for that we have to rationalize this complex number. So first copy this. And then rationalize it. So cos pi by 7 minus I, in fact plus I sin pi by 7. In rationalization, we opposite this sign. So plus. So cos pi by 7 plus I sin pi by 7. Now multiply both numerator and denominator very carefully. See, these two are same. This has power 4 and this has power 1. So this will become power 5 altogether. So cos pi by 7 I sin pi by 7 whole power 5. In denominator, we will get a square minus b square. In numerator, we can shift this power here. This 5 can come here and here. So we have cos 5 pi by 7. This power comes in angle. And I sin 5 pi by 7. In denominator, we have cos square pi by 7 plus sin square pi by 7. See, this I square is minus 1, so this is positive. And this entire thing will become 1. So finally we have cos 5 pi by 7 plus I sin 5 pi by 7. In denominator we have just 1. This entire thing is equal to 1. So I'm not writing 1 in denominator. So this is the simplified form of u. and remember this angle is argument of u. Therefore argument of u is 5 pi by 7. Remember this polar form, trigonometric polar form. R cos theta I sin theta. This is the standard trigonometric polar form. So argument of u is this angle 5 pi by 7. Part B. The complex numbers u and u steric are plotted on an Argand diagram. I mean this one and its steric. So this is a rough sketch for your conceptual clarity. See, this is u, let's suppose. So its conjugate must be here, because conjugate is always the reflection in x-axis, real axis in fact. This is imaginary axis and this is the real axis. If this is 5 pi by 7, then this must be negative 5 pi by 7. Describe the single geometrical transformation that maps u onto u steric. So this is reflection in real axis, and state the exact value of argument u. We just need to mention it is reflection in the real axis and argument u steric is minus 5 pi by 7. So this question is over. Check this solution. I'm taking 1 minute break, then I will do the next question. I'm doing 20-20-20 rule. You should also do that rule. This is good for our eyes health. So after every question, just do 20-20-20 rule. Now the next question. Is question number 8 of November 24, paper 3-1. Okay, given that z is 1 plus yi and y is a real number, express 1 upon z in this form as a function of y. So we have to do rationalization. Therefore, 1 upon z is one upon yi and do rationalization simultaneously. 1 minus yi, 1 minus yi. So we have 1 minus yi in numerator, and in denominator we will get 1 plus y square. How? Because this will become a square minus b square, and that will become 1 plus y square, because I square is minus 1. Now break the LCM, because we have to give our answer in this form. So 1 upon 1 plus y square minus y upon 1 plus y square I. That's it. This is 1 upon z. Now the next part, and next part is very important. Show that this is equal to 1 upon 4. Before starting this part, let me tell you one very important thing. You have done in P1 equation of circle x minus a whole square y minus b whole square is equal to r square. We have done this. So this is of this type. This equation is similar to this. X is replaced by a, y is replaced by b. You can write this as a minus half square, b minus 0 square, 1 upon 4. So this is the equation of circle with center at half comma 0 and radius 1 upon 2. 1 upon, the square root of 1 upon 4 is 1 upon 2. In complex number, you can say it's an equation of circle with center at half plus 0i and radius is half. So this thing will help you to answer the last part of this question. Now coming back to this part, we have to prove this equation, and for that we have a, this is a and this is b. We just need to substitute a and b into this equation. So a is 1 upon 1 plus y square minus 1 upon 2 copied, and b is minus y upon 1 plus y square whole square. Now we have to prove that this entire thing is equal to 1 upon 4, and for that we need to expand both the expansions. So first take LCM, or you can directly expand this. It's better to expand this directly. A square minus 2ab this was like that. So 1 square is 1, so I directly wrote 1 plus y square whole square plus b square, which is 1 upon 2 square, so 1 upon 4. Here we have y square 1 plus y square whole square. I distributed this power 2 to both. Now these twos will be cancelled. So we have 1 upon 1 plus y square whole square. Here we have 1 upon 1 plus y square, 1 upon 4 copied, and y square upon 1 plus y square whole square. Is equal to 1 upon 4. Now take 1 upon 1 plus y square, this thing 1 plus y square common from these three. So we have 1 upon 1 plus y square common. So here we'll get 1 upon 1 plus y square, because 1 power is common. We have taken 1 power common. So here we will have just minus 1. This will become y square 1 plus y square, that's it. And this 1 upon 4 is here. Now take the LCM. When you will take the LCM of these three, you will get, first copy 1 upon 1 plus y square. A lot of algebra is involved, so do it very carefully. 1 plus y square is LCM. So 1 is here. So when you will take the LCM here, you will get 1 plus y square in numerator here, and this minus will convert both into negative numbers, and this is copied y square. 1 upon 4 is equal to 1 upon 4. So see, 1 minus 1 is 0, y square minus y square plus y square is 0. So this entire thing is equal to 0. This entire is 0. So 0 plus 1 upon 4 is 1 upon 4, hence shown. You can check this solution again. This part B is very important. Now the next part. On a single organ diagram, sketch the loci. Real part of z is equal to 1. That means x is equal to 1. A vertical line of x-intercept is 1. And this means circle with center at half and radius half. So this is the center, half. So this should be 1. This is 1. And this is x is equal to 1. Or real part of z is equal to 1. Label the x's. Make sure you must label the x's. Otherwise you will lose 1 mark. So this is half I radius minus half I. Since radius is half, so this is half I. Done. Next part. The complex number z is such that real part of z is 1, means this one. Use your answer to part B to give a geometrical description of the locus of 1 upon z. So first observe part B. This is part B. We had to show this thing. So copy this here. And I already have told you that this is the equation of circle with center at half and 0I and radius is 1 upon 2. Let me give you a reference. A minus half, first reference of P1, circles x minus a whole square y minus b whole square is equal to r square. This equation is similar to this. Now let me convert this into that form. A minus half b minus 0 square whole and 1 upon 4. So the locus of 1 upon z is a circle, center at half plus 0I and radius is 1 upon 2. You must be thinking why 1 upon z? because we use 1 upon z, these results here and here, this here and this here. That is why this is the locus of 1 upon z. I hope everything is going smoothly. I'm checking your comments. No problem till now, alhamdulillah. So we have done 3 questions, alhamdulillah. 3 important questions. Now, before starting next question, let me take 1 minute break. You can also take 1 minute break. In online classes, we should regularly take breaks to apply 20-20-20 rule. So 1 minute break. Yes, you can get the videos from playlist. There are videos on complex numbers, differential equations, and vectors. Yes, all videos are available. You just need to check the playlist. Check the playlist of P3 full course. You will get everything on that playlist. Check the playlist of P3 full course. Also, check the playlist of P3 tips. Now the next question. Alhamdulillah, we have done all 3 questions of November 2024. Now June 24, question number 9. Yes, this is also an important question. So this question is from June 24, paper 3-2, question 9. The complex numbers z and omega are defined by this and this. Express z omega. This is very simple. We just need to multiply them. One minus I minus 3 plus 3 root 3I. Now multiply them very carefully. So when you will multiply this with 1, you will get the same thing, minus 3 plus 3 root 3I and minus I. So plus 3I minus 3 root 3 I square. So we have minus 3. See, this will become plus 3 root 3 because I square is minus 1. So plus 3 root 3 and take I common from these two. So we have 3 plus 3 root 3 I. That's it. Express part B, z and omega in r, e, I, theta form. Very simple. R is positive and theta lies between minus pi and pi. Exact values of r and theta. So you all know r means modulus and theta means argument. So get the modulus of this complex number. This is r. So minus 3 plus 3 root 3 square plus 3 root 3 square. Since square is here, so we can write this as, or you can just switch them to make it easy. Write this as 3 root 3 minus 3. One very important thing, if we have a minus b whole square, then we can write this as b minus a whole square. They both mean the same thing. But to keep the calculation simple, I just switch them. You all can manage this calculation. So when you will square this, you will get 9 times 3, 27. Then 2 a b plus 9. Here 9, 2, 3, root 3, 3 and 27. So these two terms will be cancelled. This one and this one. Now check these two. 27 plus 27. Okay, just 1 minute. I thought I had to convert this into this form, but the question is z in this form and w in this form. So there is no need to do this. We have to separately convert z into this form and w into omega into this form. So z is 1 minus I. So its modulus is under root 2. And sketch 1 minus I for argument. Make a rough sketch. 1 minus I. So it must be here. So this is y is equal to minus x. So its argument is minus pi by 4. Therefore, argument z is minus pi by 4. Hence, z in r, e, I, theta form will be under root 2 minus pi by 4 I. So this is the r, e, I, theta form of z. Similarly, find modulus of w, modulus of this. So this will become 9 and this will become 27. So 36, which will become 6. Nine, 27, so 6. and for its argument make a rough sketch. It's minus 3 and 3 root 3i, so it must be in second quadrant. So this is alpha and its argument is pi minus alpha. Make sure you do all these calculations in radian mode. So argument omega is pi minus tan inverse 3 root 3 upon 3. So this will become pi minus pi by 3, so 2 pi by 3. Therefore, the REI theta form of this complex number is six E 2 pi by 3 I. You should check this solution. I'm taking few seconds break. Next part. On an Argand diagram, the points representing omega, z omega are A and B. Prove that OAB is an isosceles triangle. So first sketch both the complex numbers. So this is minus 3 omega. Omega is minus 3 root 3i. Three root 3i. So this is omega. And the second complex number is z omega, which is this minus 3 plus 3 root 3 and 3 plus 3 root 3. Minus 3 plus 3 root 3 and 3 plus 3 root 3. You can convert these numbers in decimals and check the positions. Rough sketch. It's a rough sketch. So this is z omega and this is omega. So that's the triangle OAB. A is omega, this is A, and B is z omega, this is B. Now we have to prove that this triangle is isosceles. For that, we have to find the lengths, this and this. See, this is the longest side, so this can't be the side of isosceles triangle. So I'm finding length of A, this one. So this is omega, and we already have its magnitude here, 6. So the length of this complex number is 6. OW or OA. Now get the length of this number and then this one. First find AB. So how will you find length of AB? This is very simple. You have two options. You can either use vectors like head to tail rule. See, according to head to tail rule, first move horizontally and then vertically. This is the head to tail rule. Okay, so see, we are going on right side, so this minus this will give you this length. Let's suppose, to make it simple, let's suppose this is 2 and this is minus 3. So 2 minus minus 3 will become 5. So this minus this will give you this length. So 3 plus root 3 minus 3. So you will get under root 3. So this length is under root 3. Let me do one correction. This is 3 root 3. So 3 root 3 minus 3 will give you 3 root 3. And this is very simple. This minus this will give you 3. So this vertical length is 3. This is 3. So AB is 3 root 3 plus 3i. Now get its length. AB modulus. So this square is 27 and 3 square is 9. So its length is 6. So this length is 6. So two lengths are same, OA and AB. So this triangle is isosceles. So just write as OA is equal to AB is equal to 6, hence shown the triangle is isosceles. The other method, if you are finding this method difficult, this one, then there is another method. Method 2 for AB. You have done in vectors, you write AB as OB minus OA. So do in this way. So this is OB. OB is here. This is OB. So just copy this OB. And OA is minus 3 plus 3 root 3I. Minus 3 plus 3 root 3I. So this is the another way. So when you will simplify this, you will get 3 root 3 plus 3I. So I've done both the methods. I personally use head to tail rule, this one. But for those who find it difficult, they can do in vectors way. AB is OB minus OA. This is AB, get its magnitude, and then prove the triangle is isosceles. Okay, last part of this question. Prove that tan pi 5 pi by 12 is equal to this. Now you have to observe this very carefully. See, this number, you can find these two numbers in z omega. If you observe z omega carefully, you will see that both numbers are here, this and this. We always do this part with the help of previous parts, and it's mentioned use the part B. I will use this part B. First, understand that if I will find argument of these two, then this will come in numerator and this will come in denominator. Z omega is in first quadrant. It's here. This is z omega. If I will find its argument, I will get this thing. How? Look. This is in first quadrant here. So its argument is tan inverse 3 plus 3 root 3 over minus 3 plus 3 root 3. If I will take 3 common from minus 3 common from denominator and 3, minus 3 is common from denominator, so I'll get root 3 minus 1 here, root 3 plus 1. See, I have got the same thing, this. and we can write this as, according to properties of argument z plus argument omega is equal to tan inverse root 3 plus 1 root 3 minus 1. Now argument z, this is, we found this in part B, it's minus pi by 4, and argument omega is 2 pi by 3. So minus pi by 4 plus 2 pi by 3. And here we have tan inverse, same thing in fact. Just copy this. Now take the LCM of 2 and simplify this. So the LCM is 12. I'm doing this here. 12 minus 3 pi, 8 pi. So 5 pi by 12. This calculation is simple, so I'm doing this directly. Tan inverse root 3 plus 1 root 3 minus 1. Finally we have got, bring this tan on left side. Tan 5 pi by 12 root 3 plus 1 over root 3 minus 1. That's it. This is what we had to show. We have done 4 questions, alhamdulillah, and all 4 questions are very important. Okay, 1 minute break and then I will do the last question. The negative sign of minus 3. Okay, let me check this. Let me do one correction. This is not negative. This is positive. This is positive. When we will take 3 common from these two, we will get minus 1. Let me change the color first. Okay, when we will take 3 common from these two, we will get minus 1 plus root 3, which will become root 3 minus 1. So there is no need to take negative common. Thank you for asking. The one in denominator of, yes, I have explained it, I guess. This is positive, right? This is not negative. Thank you for asking. Thank you. You are watching the lecture very carefully, Umar. It's great. Okay, the next question is of June 24, paper 3-1, question number 4. Yes, this question. Okay, the complex number u is given by -1 minus root 3i, and we have to express u in this form, and for that we must have argument and modulus of the complex number u. So the first part is very simple. Modulus u is under root -1 square plus root 3 square. This will become 2, and this is basically r. Now for argument, make a rough sketch. This complex number is in third quadrant. Remember, for argument always make a rough sketch. So its argument should be minus pi plus alpha. So argument of u is minus pi plus alpha, and alpha is tan inverse root 3 upon 1. Remember, while finding alpha, ignore negative signs. What if we had -1 plus root 3i? While finding alpha, ignore this negative. Just write tan inverse root 3 upon 1, because alpha is always acute. Now minus pi, tan inverse root 3, it's I guess pi by 3. So the answer is minus 2 pi by 3. So that's the argument, theta. So finally, u r, first copy the form, trigonometric polar form, and then substitute the values of r and theta. Minus 2 pi by 3. I sine minus 2 pi by 3. That's it. Can you sketch what to do in each quadrant? Yes. After this question, please remind it to me. I will let you know how to find complex numbers in all 4 quadrants. Okay. The complex number v is given by this. Express v upon u. So v is 5 cos pi by 6, I sine pi by 6, and u is 2 cos minus 2 pi by 3 plus I sine minus 2 pi by 3. Now understand this very carefully. So r, we have to express this in terms of this. So for that we need r. So r is 5/2. This is the R. And for argument, use this. Argument V/U is argument V minus argument U. We have argument V, it's pi/6. This is pi/6 and argument U is here, minus 2 pi/3. So pi/6 plus 2 pi/3. This will become 5 pi/6. Therefore, U upon V V upon U in R E I theta form. So R is 5/2 and theta is 5 pi/6. That's it. Now check the solution. Well, I will share the link of this file after this class in the description, so you can get the PDF of this file. Okay, one last question of complex number. This is question number 7. This is the last question of this class. And after this question, I will explain how to find argument or alpha in different quadrants. After this question, okay? On a single argand diagram, sketch the loci given by the equations. This is the equation of circle with center at 3 minus 2i and radius 2. And this is the equation of perpendicular bisector with complex numbers. Bisector of 3 minus 2i and minus 3 plus 4i. Make sure you take common negative because these signs are standard signs. These must be negative. This one is also negative. Real part of Z, imaginary part of Z. Now circle with center at 3 minus 2i. This is 3 minus 2i. This is 3. This is minus 2i. This is minus 4i. This one. This is 2i. And this is 4i. Now bisector. 3 minus 2i is here. Now I need minus 3 plus 4i. So this is minus 3 and 4i is here. So this is here. So this is minus 3 plus 4i. Now perpendicular bisector of these two. This is the perpendicular bisector. Now the next part is, hence find the least value of z minus w. So w is here on this line on bisector and z is on the circumference. For the least value, w should be here because shortest distance least value means, and z must be here. And this is the requirement. This distance is required. This one. This is known as z minus w. Least. So first we will find this total length and then we will subtract radius from it, and radius is 2, I guess. Yes. So for this length, let me correct the scale. In this diagram, if I won't take correct scale, then this will create problems. So first I have to take a proper scale on both the axes. So this is 2i, 4i, so this is also 2, this should be 3, minus 2, minus 3. This is negative 2i, negative 4i. Now draw the circle. Of radius 2. This is better. Okay, so this is 3 minus 2i, and minus 3 plus 4i is here. Now draw these two, connect these two, and then draw the perpendicular bisector of these two. So the perpendicular bisector of these two is this. And this is 1 I according to scale. And Z is here and W is here for shortest distance. Now we need length, this length. So we have these points, 3 minus 2 and this complex number, and 0 plus 1i. We just need to subtract these two. So 3 minus 0 is 3, minus 2i minus I is minus 3i. I subtracted these two. Now take the modulus of this complex number, because I need the length of this complex number. So 9 plus 9, which is under root 18, so 3 root 2. So this total length, this length is 3 root 2. And this radius is 2. So this length, Z minus W least, is 3 root 2 minus 2. That is the least value. So whenever you draw Argand diagram, then take same scale on both the axes. Otherwise, it will create problems. And it is compulsory to take same scale on both the axes. Now this class is over. Now the last thing, quadrants. How to find complex numbers in different quadrants. Okay, I can do that thing here. So remember, this is the domain of complex number, argument of complex number. This is the fixed domain. this domain is fixed in complex numbers. This minus pi means you can work in clockwise direction till here, and pi means you can work in anti-clockwise direction till here. Walaikum assalam wa rahmatullahi wa barakatuh. One of my friend, Sir Ishaq Khan Niazi. Jazakallah, sir. He is the Islamic teacher in St. Michael's Convent School. He is one of my best friend. Okay, so when complex number, so I told you the domain of complex number is always minus pi to pi, and minus pi means work in clockwise direction from positive real axis to negative real axis, and pi means work in anti-clockwise direction from here to here. Now what if your complex number is in this quadrant, first quadrant, and in second quadrant? There are 4 possibilities, here and here. So first do this one. Let's suppose complex number z is here, so its argument is alpha. This is theta and this is also equal to alpha. So argument of z is alpha, which is tan inverse b upon a. Now if your complex number is in second quadrant, suppose this number is v, then argument is pi minus alpha. So you have to write argument v pi minus, okay, I'm writing complex number as well for your conceptual clarity, minus 2 plus 2i. Let's suppose this is the complex number. So tan inverse 2 upon 2. Remember, when you find alpha, you always ignore negative signs. So just write 2 upon 2. Now, if your complex number is in fourth quadrant, for example, u is 3 minus 2i, then its argument will be, just one second, argument of u is negative tan alpha. It's negative alpha in fact. So negative tan inverse 2 upon 3. So if complex number is in fourth quadrant, then the answer is minus alpha. If first quadrant, alpha. Second quadrant, theta is equal to pi minus alpha. In fourth, theta is equal to minus alpha. In third, if your complex number w is here, for example, the number is minus 2 plus minus 3i, so its argument should be minus pi plus alpha. So minus pi tan inverse 3 upon 2. I hope you have understood this. Okay, the question of Umar Sahab is, sir, why not calculate from origin, just one second, origin till middle of circle, then subtract the radius. Okay. Now see the diagram. See, this is the bisector of these two complex numbers. Minus 3 plus 4i is here, right? And 3 minus 2i is here. Okay. Now draw the bisector of these two complex numbers, these two. So this is the bisector. This bisector is not passing through origin. What if the bisector is passing through origin? Then find this distance, no problem. But bisector is passing through this point. This is the scale drawing, and you have to do scale drawing. So in CIs, when you will draw argon diagram, I mean, you have to do it scale drawing. I mean, take equal divisions or equal widths on both the axes. Then you will get your correct answers. And one more thing, this should be in broken form. This is the perpendicular bisector of these two complex numbers. Anything else? I hope this lecture will help you to understand how to solve complex number questions. If this lecture helps you, then kindly share the link of this lecture to your friends, and you should subscribe this channel and also ask your friends to subscribe the channel. Good luck to everyone. Good luck for P3 exam, and I will make a short lecture for the tips of P3 most probably later today. How to prepare for the last minute preparation for P3. Okay. Thank you everyone. Good luck and Allah Hafiz.